Hello, beautiful people. Right now, I'm going to do an example for how to find rational roots, going through the steps that were in your notes, but maybe were a little bit confusing for some people. So I'm going to do this one example and make sure that you are all okay with it. First thing that I do is read the problem. Find all of the rational roots of f of x equals x to the fourth plus 4x cubed plus 7x squared plus 16x plus 12. And my first thing is to reference back to the rational root theorem, which basically tells me how to find the possible rational roots. Remember, roots is just another word for x-intercepts or solutions. Yep, those are the ones I can think of. So this was where we had the p over q, the factors of p over q. And this was my p and this is my q. It's kind of a nice thing when the q is 1. And then I'm really just looking for these factors. So I'm going to list them accordingly. What are the factors of 12? Well, the factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 1, yay for us, are just 1. The other thing that I want to note is that these can be the positive or the negatives of these numbers. Now, because it's only over 1, we're kind of winning a little bit. So because we just had a 1 for the q, it's just 1 over 1. So it's 1. 2 over 1 is 2. 3 over 1 is 3, 4, 6, and then 12. I don't really have to make them fractions because it's just over the number 1. These are the list of possible rational roots. Now, because this is the fourth power, I'm going to tell you there should be 4 solutions / roots / intercepts. And so we're trying to find which ones are rational. There could be some imaginary ones. There could be some that are irrational ones, meaning you have a square root that's not perfect. So in order to narrow this down, if I let you use a calculator, a graphing calculator, then I would graph this on there. So I would go to y equals, and I would enter this into my calculator. Now you can do this along with me, or you can kind of just watch, but I'm going to kind of invite you into my head as I do this. And so I've entered in the equation, and if you need a little bit more time to do that on your own, you can press pause. So now that you've entered it into your calculator, I don't want to hit enter yet. I'm not going to graph. Well, you can, but I am also going to change my window to one that's actually going to help me out a little bit, because I don't need to see the whole world with this function. I kind of know that my rational roots are somewhere between this list of numbers. The biggest number on here is 12. So when I am doing, so I'm going to go ahead and go to my window. When I'm doing my x minimum, I want the smallest number. People will look at this list and they'll be like, oh, the smallest number is 1. Not so much, because remember, it's the positive and negative of all of these numbers. So my smallest number is actually negative 12. So when I do my window, I'm going to give myself a little bit of a buffer and make negative 13 my x minimum. And then I'll make positive 13 my maximum, just to give me a little bit of wiggle room. I know that the biggest number is 12, but I'm going to go to 13, and I'll put a 1. And now the y minimum and y max, this is what I'm using. I'm always going to use negative 1 for the y min, positive 1 for the y max, and a scale of 1. Why? Because at the end of the day, I don't really care what's going on way up here or way down here. I only care about where it hits the x-axis. So I'm just going to look at it from negative 1 to 1, because who cares what's happening above that? I just care about where it's at when y equals 0. So I give myself a little bit of a buffer from there. Okay, once you have set your window, go ahead and hit graph. And you should get something that looks a little something like this. Might look a little bit different if you're on the Inspire, but looking at it, you should be able to see that your graph crosses 2 times, it looks like. Looking at that and comparing it to my list of possibilities, I'm looking at it and it looks like it crosses there at negative 1. So I'm going to write possible at negative 1 and at negative 1, 2, 3. Those are the ones that it looks like. Now, I'm going to tell you, I did pick an easy problem because sometimes it's going to be a fraction, but I just want to make sure that you see how how to do these without any gnarly things. So -1, -3 looks like where it crosses. I'm going to verify that. I'm going to verify that using synthetic substitution. I'm going to show you a nice little trick here as well for that. So synthetic, does not matter whatsoever which one you pick first. I'm going to use my coefficients from the original problem, which were 1, 4, 7, 16, and 12. If this is a 0, then when I do it, this last number should be a 0. Should be. Let's hope that it is. Okay, remember my steps. Bring down, and then I'm going to multiply and add. Multiply, -1, add 3. Multiply, -3, add 4. Multiply, -4, add 12. Multiply, -12, add 0. Wonderful. I have just verified that that is indeed a 0. So this -1, check. Of all of the rational roots that I just listed, these are all the possibilities in the whole wide world. I have just found that -1 is one of them. Now I'm going to verify this -3. But I'm not going to do a whole new substitution synthetic deal. I'm going to continue on something a little new for you. I'm going to continue on, and so I'm going to now do the -3, and I'm going to bring down 1, multiply and add, multiply and add, multiply and add, and I get 0. I'm going to tell you now, this is goals. No matter what you are starting with, the goal is, and once you do, the goal is to get this down to where you only have 3 terms outside of the 0. Outside of the remainder, this is the goal. Because once you do have this, you can write this as a quadratic. Because remember, this is your remainder. Hey guys, this is your remainder. This is my constant. This is my x term, and this is my x squared. The reason why I wanted to get it to where it's at this level is because I'm looking at x squared plus 0x plus 4 equals 0. I can simplify this, and I can solve it. Even if there was an x term here, I could solve it by either factoring, or I can solve any one of these by using the quadratic formula. That's why my goal is, if I can get it down to 3, I'm in great shape, because I can solve those every day, all day. Okay, so I will solve this. It's a little bit easier that I don't have to factor. I don't have to use a quadratic formula. I'm going to have x squared equals -4, and I'm going to square root and square root, and I have x is equal to positive and negative 2i. Okay, Houston, my directions were to find all of the what? Let's go back. Find all of the rational roots. That's what I was asked to do in the very beginning. Have I done that? Kind of. This is not rational. It's not even real. So I can include that, you will, when we do the 5.6. But for this, I can only verify that my rational roots are -1 and -3. When you get to this point, they'll probably, today for 5.5, they'll probably be actual rational roots for you. But for this, they're not. So I'm not going to count them because they only asked me for the rational ones. Okie dokie. Hopefully that clears things up. That's the same process you're going to do for all of these problems that are like this. You do need your calculator. If you can't use a calculator to check them out graphically and see what it looks like, as we did here, then I'm giving you my personal guarantee that either 1 or -1 will work. Or I'll give you a hint to help you start off. But if otherwise, you'll be able to use your calculator to do that. But thank you for joining me, and have a great day.